I have released a new version 1.6.4 of the IoTT Stick software, and in this video I'm going to show you the new features. One is a new WiThrottle client that can be used with the purple hat for speed matching and speed table programming. And the other is support for the new track manager features of DCC EX version 5. Besides that, I was able to get the badge of the original IoTT Stick devices, so you now can choose between the IoTT Stick Plus and the cheaper standard IoTT Stick. More information about the available options in the third part of this video. Welcome to the IoTT channel, I am Hans Tanner. A special welcome for all new viewers and welcome back to everyone else. I'm happy you made it here and I thank you for your interest in my channel. As you might know, the YouTube algorithm promotes videos based on watch time, subscribers and likes. So I appreciate if you watch this video to the end or at least a little longer. Click the like button and hit subscribe if you are not already a subscriber. The first new feature I added is a client for the DCC EX WiThrottle protocol that can be used with the purple hat sensor. The advantage of this client over the standard WiThrottle protocol is that it allows for programming the CV values of the decoder directly from the IoTT stick, similar to when using LocoNet over TCP. Here is how it works. In the purple hat node configuration, select WiThrottle Client DCC EX as your command source. Click Save and Restart and then use the WiThrottle page to connect the IoTT stick to a WiThrottle server. This typically is a Wi server running on a Wi-Fi equipped DCC EX system, but it can also be another IoTT stick, either connected to LocoNet or sitting on a DCC aux or Red Hat Shield and acting as Wi-Fi port to the DCC EX command station. Of course, this would be somewhat unusual, as in this setup you probably would use the more powerful and flexible LocoNet over TCP protocol. When connected, open the Speed Matching tab of the purple hat and load the JMRI roster file with the decoder definition for your locomotive. Run the speed analysis process as before, and the locomotive will move back and forth to analyze the speed characteristics. But now, once the speed table is calculated and displayed, Speed Matching will also show a Write CV button that allows you to directly program the decoder either on the main track or on the programming track. Same as when running LocoNet over TCP, and it is no longer necessary to first save the JMRI roster file and use Decoder Pro for programming the speed table CVs. It all can now be done in one single cycle. If you want to start using the new version, you can download it from the GitHub page and install it on your IoTT stick. As shown in various other videos, download the zip file and save it to your hard drive, connect the IoTT stick via USB to your computer and run the batch file to install the software. This simple process takes about 2 minutes and you're ready to run. Furthermore, it is a good idea to save your configuration settings on the hard disk before you start the update process, so that you can reload your setup after installation of the new software version. But now, on to the second new feature. The DCC EX team has recently released version 5 of the DCC EX software, and it comes with a new functionality many people have been waiting for. The track manager. Instead of having predefined main and programming track outputs, you can now define up to 8 track outputs and configure them either as main or programming track. Of course, you can only have one programming track, but you can select any of the defined track outputs for that purpose. If you are running DCC EX on an Arduino Mega, you can also configure each output as a DC track and assign a DCC address to control the voltage. Now, more technically speaking, it is a PWM output and the DCC address is used to control the duty cycle. It is important to understand that this configuration happens in two steps. First, you define the hardware in the motordrivers.h file. As before, you enter one line for each track output and define pins for power and DCC signal, as well as an analog pin for current sensing. If you want to use the new DC feature, you also need to define a break pin. The second part is defining the output mode. Note that it is not possible to define it permanently as the mode resets at startup, and the Arduino defaults to main for channel A and PROG for channel B, which I think is to ensure backwards compatibility. Also important to know is that mode information is not saved in the EEPROM if you choose that option, which I think is a minor inconsistency with how DCC EX treats other setup information such as inputs or turnouts. Long story short, you have to configure the output modes each time after rebooting the Arduino. You can do that either in the opening sequence of the X-Rail script, or you can transmit the information using the serial port, and this is where the new IoTT Stick software is adding a layer of convenience. As soon as you load the Red Hat configuration page, the DCC EX software version is detected, and if it is version 5 or higher, the Track Manager tab is activated. The track outputs configured in the Arduino are then interrogated and the result displayed along with the mode settings. You can now select the desired mode from the drop-down list, and in case you select a DC mode, you can define the DCC address used to control the track. Note that the DC options are only available if DCC EX is running on an Arduino Mega. Each change you make is immediately written to the Arduino, and the track signal changes accordingly. When you are done with the configuration, you click Save and Restart, and the settings are written to the IoTT Stick flash memory. From now on, every time the Arduino reboots or the Red Hat web page is reloaded, the Arduino settings are updated from the IoTT Stick. And of course, you can always go back to the configuration page and make changes as you wish. Let me do a quick demonstration of the Track Manager functionality. I have an Arduino Mega and 4 power shields stacked on each other. On top, I have a DCC aux shield with the IoTT Stick. Here is the configuration code I use to configure the power shields in the DCC EX sketch. As you see, the first 2 power shields use the same pin configuration as the standard motor shield, except that I have added a pin number for the break pin. The next 2 shields use their own set of pins, and you can get information on what pins can be used for what purpose in the DCC EX documentation. I then compile and download the sketch to the Arduino Mega, and after reboot I open the configuration page of the stick. I choose Loconate Loopback as command source and Red Hat Shield as hat module. When I now open the Track Manager tab on the Red Hat page, the 4 Power Shield track outputs appear in the track list. The first 2 are set to main and PROG, and the second 2 to none. I now use the drop-down selectors to change the track modes. What I want is track A and B as main tracks, track C as DC track, and track D as programming track. For the DC track, I want to use DCC address 25 to control the output voltage. Note that the modes are immediately updated on the Arduino, but to make it really permanent, I click Save and Restart to store the settings in the IoTT Stick flash memory. With all configuration complete, I am ready to do some testing. Here's a table showing what signals I should see on which Arduino pin, and it is worth to have a closer look at it to gain a better understanding of the inner workings of DCC EX. First, the DCC tracks. Here it is important to know that the DCC signal is permanently active, independent of the status of the track power. Switching the track power on and off is done with the power pin. If I connect the oscilloscope to the PWM pin of the main and programming tracks and the track power is off, I see two independent DCC signals. If I run the signal through a DCC analyzer, I see that the main track is sending emergency stop locomotive commands, and the programming track is apparently sending some invalid packets, but the track power is off anyway. If I turn the track power on, the power pin is activated on the main track outputs, and active locomotive commands are sent out. Interesting to see that if a DCC address is used to control a DC track, the speed information for that address is still updated in the DCC signal. The programming track keeps sending invalid packets while remaining unpowered and only becomes active and sending valid packets when I issue a CV read or write command. If I send a one join command, then I see the power pins go up on all main and PROG outputs. Now the PROG track is duplicating the signal from the main track as long as no CV read or write command is issued. That means that the join feature is still available in version 5, which is good. And as in previous versions of the IoTT Stick software, you can activate it by checking the checkbox labeled main signal on PROG track on the Red Hat setup page. A comparison between track A and B shows that the DCC signals on both tracks are identical, which is as expected. So if you configure several outputs as main, they will all carry the identical DCC signal, and the power on and off commands will control the power pins of all of them simultaneously. Now for the DC track, which is slightly different. The power signal still controls the track power, but the PWM pin is now used to control the polarity or travel direction, and the brake pin controls the voltage that is sent to the locomotive, in other words, the duty cycle of the PWM signal. On the power shield, the travel direction is indicated by the color of the track LED, either red or green, and the output voltage is proportional to the brightness of the LED. That's just a first glimpse, as I plan on doing another video covering the details of the DC track output sometimes in the near future. So stay tuned, subscribe to the channel and hit the bell icon so that you won't miss any future videos. And now, as announced in the intro section, a quick look at the changes I made to the IoTT Stick product page in the Tindie store. So far I have shipped all sticks with growth port cable, a mounting bracket and a USB charger cable. First, this was the case for the standard stick, and then, when it was no longer available, for the IoTT Stick Plus as well. Now, if you have several sticks, as many of my viewers do, this is somewhat redundant, as probably nobody needs 5 USB charger cables. So I have changed the product page on Tindie to make the accessories optional. And since the standard stick became available again, the stick type is now an option as well. So when ordering an IoTT stick, you start with the standard stick and add options as desired. The first option lets you upgrade to the Plus version. The difference between the standard stick and the IoTT Stick Plus is in the display size and resolution and the battery capacity. The CPU power and all other features are identical. So if you plan on using the stick on a stationary function hat, such as the blue hat, or yellow hat, brown hat, green hat or red hat for that matter, the standard IoTT stick is sufficient, as these hats have their own power supply. Where it really pays off to use the IoTT Stick Plus is when you use it with a purple hat, as it runs on battery and you gain extended operating time before you have to recharge. The subsequent options let you select the length of the growth port cable and whether you want a mounting bracket and USB charger cable or not. It is my hope that these changes make it easier for you to get what you really want and save you some money by not having to buy items you do not really need. And that's it for this video. I hope this information was useful or at least interesting for you, and you have now a better understanding of the new features of DCC EX and how the IoTT Stick is supporting them. If so, please click the like button below to let me know. Also, feel free to let me know your opinion or questions in the comments section of this video. I always like to hear from my viewers and appreciate your feedback. Thanks for watching and see you in the next video.